Hello, we're going to start talking about lesson 5 today in chapter 8, and this is on page 196 in your textbook, so make sure that you're to that point. I just want to talk about the difference between the last lesson and some previous lessons and this lesson. So we've done multiplying a whole number and a fraction before, but the difference is that when we did that, the only fraction model we really had was when we take some object and cut it into equal pieces. Right, but now we have from lesson 4 this new model that a fraction can be part of a set. So for example, if we wanted to do 3/4 here, it would be this one object cut into 4 equal pieces and we get to keep 3 of them. But now with this new set model that we have, we're taking a collection of 4 things and we get 3 of them. Right? So we're breaking it up into 4 equal groups, and then we get 3 of those sets, the smaller subsets. All right, so here's what we have today. Emma has 16 coins in her collection. So again, you notice that these now form a set of objects like this, where they're distinct objects, not a single object broken up. She has 16 coins in her collection. 3/4 of them are silver colored, so one's like this, and the rest are copper colored coins. All right, how many silver colored coins are there? The first thing that they're asking us to think about is, will the answer be more or less than 16? Right, so what this is saying is we want to break our set of 16 coins up into 4 equal groups, and then we only get to take 3 of those 4 equal groups. So hopefully you're realizing that with only some of the groups, only 3 of the 4 groups, we can't possibly end up with more than what we started with. Right, so because this fraction is asking us to take less sets than the number of sets we've formed, we have to be less than 16. Right, and again, as long as our fraction is a proper fraction, right, where the numerator is smaller than the denominator, where we get less sets than there are sets, this will always be true, that we'll always have less than what we started. Even if they change the fraction to say something like 5/8, or if they change the number of coins from 16 to 40, we will still end up with a smaller amount than what we started with. And again, just to give us a view into where we'll be headed, let's say they said we get, we get to have 1 3/4 of 16. So this means that we get all of 16 and additional. That would be a case where we would end up with more than our original amount. But as long as we're talking about just a proper fraction, just that 3/4 or something similar, we'll always end up with less than what we started. Okay, so let's take a look at what they're doing here. So what she's saying here is, if we divide 16 into 4 equal groups, so here's our 16 coins, and we're splitting them into groups of 4. How many coins are in each group? Sorry, I didn't mean to say groups of 4. 4 equal groups. We divide it into 4 equal groups. How many coins are in each group? All right, so again, she's drawn it out for us. If we had coins in front of us like we did here, we would say, oh, we want to split it into 4 equal groups. Well, let's see, 1, 2, 3, 4, 5, 6, 7, 8. That would be 2 equal groups. And then let me cut each of those groups into 2 more. So then I would have this and this. That would be our 4 equal groups. And so then I would count 1, 2, 3, 4, 1, 2, 3, 4. There are 4 in each group. So what they've done is they've just drawn a model of that for us. And again, they've separated it by silver coins and copper coins. We don't even need to do that to find out, we didn't even need to do that up here to find out how many coins would be in each group if we split them up into 4 equal groups. But they did that for us. All right, so then what they say, how many are in 3 groups? So if we make 4 equal groups, there just happens to be 4 in each group. That's coincidental. There won't always be the same number of coins in each group as there are groups. In this case, though, it was. So what she's saying, how many coins are in each group? Well, 1, 2, 3, 4. Now, what if I get to keep 3 of those groups? I get to keep this one, and this one, and this one. I have 3 groups out of 4 equal groups. So how many would that be? Well, that would be 4, 8, 12. So let's do the symbolic way here instead of the visual way and see how that looks. Sorry, I hope I'm not cutting off at the bottom here. So if I take 1/4 of 16, again, that means break 16 into groups, into 4 equal groups, and I get to take one of them, right? Break 16 into 4 equal groups, I get one of them, right? And so what we're doing is we're taking 16 and we're dividing it into 4, so we're breaking it apart into 4 equal groups. 16 divided by 4 is 4, and so that this is telling us then that in one group there would be 4 coins. Now that we know how much is in one group, now we're going to say, okay, well then 3/4 of 16 means that I want to break it up into 4 equal groups, and then I get to keep 3 of them, right? So what they're going to do is they're going to say, well, let me just figure out how much is in one group, right? Which is exactly what we did in the last part. And now I get 3 of those groups. So I'm going to take 3 times whatever I got last time. Well, what I got last time was 4, right? This was the work for that. And then I've also got the 3 to indicate that I want 3 of those groups. So 3 times 4 is 12, and this represents how much is in 3 groups. Okay, so the process here is first just dividing 16 by 4 to find out how much would be in one group of one of the 4 equal groups, and then the next step separate from that is to then multiply it by 3 to find out how much would be in 3 groups. All right, again, they're going to show us a couple different methods, so let's take a look at the second method here. So 3/4 of 16 is the number that is 3/4 times as much as 16, all right? And the answer will be less than 16. So they've said, again, they've gone back to a bar model here, and so they've said here is 16. Let's break it up into 4 equal groups and take 3 of them, all right? So if we break 16 up into 4 units, all right, again, take this long bar that they've made. Without this stuff here, it would look like this. If we just started this on our own, we would say there's 16. I need to break it up into 4 equal groups. All right, we've done ones like this on the board before. I break it up into 4 equal groups, and then I just have to figure out how much is in each group. So they've drawn that for us. They've shown that they're taking 3 of them. And then, so here it is, 16 broken up into 4 units. 1 unit has to be 16 divided by 4, which is 4, and then 3 units is 3 times those 4, which again would be 12. I feel like this looks blurry and I can't tell if it's just me or not. Let me try focusing it. Okay, and then in the third method, which is probably the one that we will use, this is saying 3/4 times 16. In other words, 3/4 of 16 is the same as 16 times 3/4. Notice that this is the way that we were doing it in the previous lessons, where the whole number came first and the fraction came second. And we can make this switch right here because if you remember from memory work, multiplication is commutative, which means it doesn't matter which order that you do it in. You can flip-flop them. So 3/4 times 16 is the same as 16 times 3/4. So I can use the same method that I did when I multiplied a fraction by a whole number. So that means, again, in the fraction times the whole number, we would have done 16 times 3/4, and we would have written this as 16 times 3 over 4. But then we remembered, oh yeah, I can do that canceling or the simplifying. So I'm going to take out that factor of 4 because 4 goes into 16, goes into 1. 4 goes into 4 once, 4 goes into 16 4 times. So 3 times 4 is 12, and then there's just a 1 in the denominator, which is 12. All right, so we did that 3 different methods. So what we end up with is there are 12 silver colored coins. All right, let's take a look at some practice problems. All right, so on the next page here, this will be page 198, find 1/3 of 12. So here we have 12 circles drawn, and they've broken them into 3 equal groups, and in each group there are 4 objects. right? So the first thing they do is they split the 12 into 3 equal groups, and we're going to notice that there are 4 in each group. So 1/3 times 12, or 1/3 of 12, is 4. In the next problem, find 2/3 of 12. We could do the same thing. We already found out that 1/3 of 12 was 4, so 2/3 has to be twice that much, or 8. But let's see that visually. So 2/3 of 12, again, here's what they did. Find 1/3 of 12, which is 4, right? And then 2/3 of that is just going to end up giving us 8. All right, so here's 1/3 was 4, and then 2/3 of it has to be twice 4, or 8. Hopefully that's okay. Again, always feel free to go back, rewind, and watch it again. All right, problem 2, find 1/6 of 18. All right, so again, we could do it the visual way, which is to take 18 and divide it into 6 equal groups. So we would do 18 divided by 6, or 18 divided by 6, like this. And we get that there would be 3 objects in each group. And then we would take one of them in 3. But this time they're moving to that, the last method that they use, which is just the same as the multiplication one that we did before. All right, so 1/6 times 18 is the same as 1 times 18 over 6. Again, we're going to simplify that first. So 6 goes into 6 once, and it goes into 18 3 times. So 1 times 3 is 3, and then it's over 1, so this would be 3 over 1, which we just call 3. All right, now again, I'm going to keep tying in these two methods together. We're eventually going to move just strictly to this one, but I want you to see why they're doing this for now. So we're going to do 5/6 of 18. Well, we already figured out what 1/6 of 18 was by taking 18 divided by 6 and getting 3. So that means that in one of the 6 equal groups, there are 3 objects. Now we get to keep 5 of them. So we're going to take the 3 that we had and multiply it by 5. And we should get 15. And we can see 3, 6, 9, 12, 15. But what we're going to do over here, again, is this numerical approach, which is like the ones that we did before. And we're going to do 5/6 times 18, right? And then they're going to say, all right, well, first we're going to find what the 6ths of 18 look like. All right, that would be 3. And then we're going to take 5 of them, which would give us 15. Okay, I'm going to pause here because the videos get too long and then my camera cuts off. So I will be back in just a minute.